All right, so now that we have the sigma notation down, how we can write, we're adding a bunch of things together, we can actually talk about these approximation methods. All right, how are we going to approximate the area under a curve? All right, so say we want to find the area under the curve, under some random curve from 2 to 4. The first thing we need to do is figure out how wide our rectangles are going to be. So let me just draw a kind of example. All right, we're trying to find, let's say, this area here, all right, encased by this blue, or this is green. All right, this green area. All right, from 2 to 4. All right, so this is x equals 2, and that's x equals 4. All right, so we're trying to find that area. And we want to partition the x-axis into kind of equal width. So let's say we want to use 4 rectangles. We're going to partition this into 4 equal parts. And this will end up giving us rectangles to use. All right, so the first thing we do is kind of figure out how wide each thing is going to be. And that's kind of the starting point. All right, so we're going to figure out how wide each one is going to be. And now the next part, after we figure out how wide each rectangle will be, is to figure out how tall the rectangle should be. So if I kind of try to redraw that picture I just had. All right, now we know the rectangles get broken up into 4 pieces, but how tall should I make the rectangle? Should I make the rectangle this tall, or that tall, or that tall? All right, that's something we have to kind of determine on our own, and it's going to change depending on which method you're using. Our first one is going to be called the left endpoint method. So if we look at this rectangle, we're going to make it as tall as the left-hand side of our function. So that's going to be my first rectangle. The second rectangle, I'm going to make it as tall as the left-hand side, which is there. I'm going to make a rectangle. All right. The next rectangle, the left-hand side's there, and you can see it's a little bit above there. All right, so this would be a left-hand approximation for the area. I break it up into 4 equal rectangles, and I use the left-hand part of my rectangle in order to figure out the height, and I would add up all these areas together to get my full area. All right, the only thing that's going to change for our next one is we're going to use the right endpoint. So again, let me just redraw a quick picture. I'll make it more exaggerated this time. Right, so we're trying to find this area from here to here. Again, I break it up into rectangles. The only difference is now I use the right-hand side of my rectangle to figure out the height. So my first height is going to be that high. My next height is going to be that high. Again, I'm just using the right-hand side of all of these, all right, to get my rectangles. And again, I would add up all these different areas, and that gives me my area approximation. So pretty much the same thing. I just use the right side of the rectangle for the height instead of the left-hand side. All right, the final one we'll talk for now is the midpoint, which is the same thing. I have my thing. All right, the area I want to find, I break it up into the equal pieces. I'm just using 4 to make it go quicker. All right, the only difference now is I use the midpoint of all these for the height. So that's going to be there, 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 and there. And that gives me the height of my rectangles. So same thing as all the other ones. I'm just using a slightly different point to figure out the height of the rectangles. But again, I take all the areas of these rectangles, add them together, and that gives me a decent approximation for the area under the curve. All right, so we'll do a quick example looking at the curve of y equals x squared. Approximate the area under the curve from 0 to 4 using 4 rectangles. So if we were to graph this, right, x squared is the parabola, like something like that. And we do it from 0 to 4. All right, so 0 is going to be here, and 4, let's just put it there. All right, so we're trying to find this area there. All right, first thing to do is figure out how wide of our rectangle's going to be. All right, so we have a distance from 4 to 0. That's a distance of 4. And then we need to break that up into 4 even rectangles. So that's going to give me, each rectangle is going to be width 1. So if I redraw this picture, I can have my rectangles. Right, there's x squared. There's 4. 1, 2, 3. All right, so each rectangle is going to have width 1. And then let's just say we're going to do a left-hand approximation. All right, so I'll abbreviate it there. All right, the first rectangle, I'm using the left-hand side of this first spot, which is at 0. If I plug 0 into my function, the height's going to be 0, because 0 squared equals 0. So this first rectangle has height 0. So that's going to be the first thing I add. All right, the second rectangle is going to be this rectangle, using the left-hand side, which when I plug that in, I'm plugging in 1 and squaring it, I get 1. And then the width of the rectangle is 1. So the height's 1, the width's 1. That's going to be area 1. Next rectangle. The left-hand side is when I plug 2 into x squared. That's going to be 4. And the last one is when I plug 3 in. That's going to be 9. All right, so my first guess for the area of this is going to be 14. What if we did the same thing with a right-hand endpoint? All right, right-hand estimate. All right, well, nothing's really going to change. The only thing that's going to change is the height I use. Now I'm using the right-hand side, so now my rectangles are going to look like this. All right, so these 4 yellow rectangles. The first one is height 1. The second one is height 4, then height 9, then height 16, which adds up to 30. All right, so you can see very different numbers, 14 and 30. You can see that the yellow has a bunch of extra areas that I don't actually want, so 30 is bigger than the answer. The green one has a bunch of extra areas that I don't hit, so 14 is smaller than the answer. So chances are the answer is going to be somewhere in the middle of those two numbers. All right, so this is how we use the rectangles to make an approximation. If we want to get closer to the answer, we would just use more rectangles. Because that's going to get us closer and closer to the answer as we make more and more rectangles. And we'll do a little practice with that in class.